If you've been following along for all the pieces, you've watched the introduction, you know what we've been doing, you've watched the implementation video, you've seen that we implemented bubble sort, and you've watched the interface video to see how you describe sorting abstractly, you define that interface. Now we're going to pull it all together, and this is the really cool part of TLA+. This is where you can actually show, are your interfaces lies? Do they actually correspond to the true behavior of your implementation? Do you take your implementation and you abstract away some details so that the caller can just worry about a smaller set of details and trust that the implementation fulfills that interface? That's the whole point. TLA Plus calls this refinement, and this is deceptively simple. It's presented sometimes as a superpower, and it seems to be kind of this complex, amorphous thing within the TLA Plus zeitgeist, I guess. But really, it's a very simple thing. We're going to see that it just takes 4 lines to relate these two specifications. So if you recall, this is the implementation video. This is bubble sort. We have our interface, which is sort by magic. And we're going to now relate these two things. So we're going to say we have a mapping that's defined as an instance of the sorting algorithm. So this is sort by magic, the interface side. We're going to say that the initial state of sort by magic matches the initial state of bubble sort. The final state of sort by magic matches the final state of bubble sort every time. They can have different number of states in between, which they do because sort has only an initial state and a final state. Bubble sort has lots of intermediate states, depending on, it has n squared intermediate states, right? So we're going to relate that these two fulfill the same interface, and that relationship is called refinement. So here you go. I like to put this comment in to help me keep track. There's the magic sort side, maps to the bubble sort side. So then A on the magic sort side maps to, if the program counter, and if you remember we bounded the program counter in type OK, this is why I did it. It was just to help me make sure that the program counter didn't end up moving because I changed something about the plus cal before I completed the refinement mapping. Done. Then A. So A on the magic sort side matches A on the bubble sort side if the program counter is done. Otherwise, it matches the initial value of the bubble sort side. So the thing we started with matches the thing we started with on the magic sort side. For every intermediate step of bubble sort, up until the program counter is done, then the two should match. That's it. That's the whole thing. That is refinement. We now express this as a temporal property, so TLC can check it. Refinement is defined as a mapping over the spec. And how did I get a if PC silly, not PC defined as done, PC is done. There we go. Perfect. If PC is done, then A, otherwise the initial value of A. And this is simply a temporal property. So let's define a new model. And this is going to be refinement demo. Again, we're going to bound our input size 2. We are going to bound the set of natural numbers, and we're going to do it correctly this time. Okay, and it is the values 1, 2, and 3. We are going to define a property, add, and we are going to refinement. Okay, you can add the other invariants in there. Doesn't matter. We already checked them in another model, so this model is just going to check the refinement. And we run it. And here, TLC is running both specifications, and it's showing that the mapping we defined is true, that the initial states match when we said they should, and the final states match when we said they should. That's it. That's refining. That's refinement, and that's how you can design your interfaces, design your implementation, and then use TLC and math to bring them together and show that they correspond. Thanks.